Good evening, friends. Welcome to Eastern Academy. And today we are going to discuss about starting a new session, electrical fundamentals. This is session 1. And today we are going to discuss about the very simple things. What is electricity? Voltage, current, resistance, power, and energy. Most of you know that. But also, sometimes we think we know that, but let us discuss from my point of view. You might have heard from the other professor point of view. Let us try to explain to you that what is this 6 terminologies. First of all, we'll discuss what is electricity. See, this all, till yesterday, these are all not playing a big role. But today, this and embedded systems are going together. You know that all the electric vehicles, EVs, you should know these things. If you do not understand the 5, this 5 is a critical. One is electricity. What is electricity? And what is voltage, current, resistance, and power and energy? This plays a big role in all the EVs. And you know that future is going to be full of EVs. The EV is multiple roles. The one of them is you see the vehicles, but next one is a solar system. Am I right? All the energy creations everywhere is embedded system. If you go to the windmill, and top of the windmill, you will find the embedded system. So everywhere it's embedded systems and how it is controlling this electricity. What is the relation? Sadly, you may be knowing a lot of information, but still, let me start as a process. I will also give you the idea about what is that. So we have some few misconceptions and terminologies wise everything that let me explain to you that's very important for us. The first one is, if I ask what is electricity, it's a very simple word. What is electricity? We always give a word, most of us. It's called flow of electron. Am I right? When I say what is electricity, we say the answer flow of electrons. But if I ask the next question, what is static electricity? Then we have a problem. Because if you say electricity is flow of electrons, then we have a confusion of what is static electricity. So actually, it's not flow of electrons. So what we do is like this. Electricity, it has 2 portions. It can divide by 2. One is static, one is dynamic. The dynamic is the one where the electron flows. In static, electrons don't flow. Now we'll ask, what is electricity then? The what is electricity is very simple. We have two materials. This has some amount of free electrons. This has some amount of free electrons. What is the difference? So normally I can call this as a electron economy. Like we have a money economy. Or currency economy. But we can call this as a electron economy. So everything is, we're talking about the electron. Proton never comes into the picture because it's much heavier. So it is there in the nucleus. That's all. Everything is all about electron. Less electron or more electron. If one guy is having less electron, one guy is having more electron. If the free electrons are same for both the material, then the difference is 0. The difference is 0. That is called 0 electrons. Okay. You understand that? That is, I have 2 material. If one guy is having 0 free electron, other guy is having so much of free electrons, so much of free electrons, both are same, then we call that potential difference as a 0. Here, you have to understand the word potential. Everything you have to understand. Potential. The potential is how much money you have. Hey, you can see, you say, that guy is a highly potential guy, man. Either potential means he has a more money or more power or more knowledge. So we use the word potential, an English word, to represent somebody, the differences. That's what I hear. Somebody has about 10,000 rupees. Somebody has 10,000 rupees. Somebody has 1 lakh rupees. This guy is more potential than this guy. He has a potential to buy a car, a bike. This guy does not have the potential to buy a bike. So that's why we use the word potential. Here, in the electricity, the potential is talk about electrons. But the normal atoms, we know that number of protons and number of electrons are same. Understand? So when they are same and the orbit is going on the orbit, that's a very normal neutral atom. But how do it's very difficult to remove the electron from the orbit or to push an electron into the orbit. What we do here is we give an energy from outside. We give an energy from outside. If you don't give this energy, nothing will happen. That means that the difference here will be 0. By giving an energy, we remove the electron from one and we add the electron in the other one. That means this guy has a more electron, this guy has a less electron. That's a trick. So the moment you make a difference, we produce electricity. This is what called generation. What is meant by generation is you are converting some energy. It could be magnetic or wind or solar or heat or chemical. Whatever it is, I don't mind. It's a chemical means battery, solar means solar panels, magnetic means motors, wind means windmill. Okay, heat means turbines, whatever it is. Forget about this. Atomic, you take even atomic. So whatever mechanism you use, that is, I'm not coming here. That is the topic of electricity. You go on the electrical subject, then you learn it. That is, this itself is a big topic in the world today. If you concentrate only on generation, you hit it. You are the most wanted person in the industry today. So please understand. So generation is nothing but I make a difference. That is, if 2 people are having 1,000 rupees each, that means that they have a same potential. They are equal. Now what I do here, I take 500 from here, I give it to him. So now this guy is having 1,500. This guy is having 500. The difference become 1,000. So one guy become more potential than the other guy. Okay, you give your money and buy a Tesla's car. Okay, Tesla become more potential than you. But if you don't buy a car, then he cannot become rich. That's a trick. Somewhere the money, here money economy, currency economy, here it's electron economy. If you don't give the force, how the force act, how the electron is getting out, how come electron is having so much of energy to revolve around the proton, these are all science. These are all science. There are 3 subjects: science, engineering, and technology. but we are discussing about technology. I'm not either good at science or engineering. That you have to talk to your professors in the college. So please understand, I make a difference. Now, in one material, there are less electrons. In other material, more electrons, free electrons. So there's a difference has come. Now, if one guy is having more money, one guy is having less money, then there's a naturally the flow will take place. Am I right? Here's the same way. As long as I don't say this guy is having 10,000 electrons, this guy is having 5,000 electrons. The difference is 5,000 electrons. Like here, the money. Let us count the electrons also. Now, as such, we leave it. This is electricity, but this is actually called static electricity. Like a battery. Like a battery, static. A battery is a static electricity, plus and minus. Here's a trick. It's just one small trick, one small mistake, not mistake. It's the way they find the invention. When the Benjamin Franklin, when he found a thing, he said that there is a particle in the middle which is very powerful, and the particle outside. I'm talking about 400 years back or not. So those days, 1700. That time, they were trying to find something from the lightning. From the lightning, he found that there is a heavier particle in the center, and there is a lighter particle in the outer. This guy is pulling him. That's what they thought. It's actually not true. They are independent. This guy is pulling him. And because of this pulling power, he called this as a positive. This guy is negative. Negative means less power, and the positive is more power. That's what he thought. That's the reason he has given. We have always started following. Protons means positive. Electrons means negative. That's the way we started. We started all these things because of our great man, Benjamin Franklin, who had given a thought like this. This is the way documents are written and people start follow. So now what happened? Later they found out that, hey, this guy is too heavy. How much time heavy? The proton is 1,800 times heavier than the electron. So because of that, proton cannot be moved. Electron only can be moved. So here less electron, more electron. The difference is 500 electron. But unfortunately, electrons is negative. Instead of saying that this guy is having more 500 electrons, they start saying that this guy is 500 protons more. Understand? That's why they call this as a positive, this as negative. This is a very simple concept. They don't wanted to represent. Here less electron, here more electron. That's why they call negative. Here they call positive. Okay. But actually the force is outside force is talking to only electron, nothing to do with proton. The plus means doesn't mean that more protons. We remove the electron, that's it. And this process, 10,000, 10,000, that's a natural. Now I make this guy as a 5,000, this guy as a 15,000. And that is process is called generation. Generation is I make a difference. So the difference is called potential difference. Since this was invented by Volta's the battery, they want to honor Volta. So they have given this as the name given to potential difference is called voltage. The name given to the potential difference. Voltage means potential difference. There is nothing called, I cannot say that one point is having how much voltage. I cannot say that. Then you know that we have a currency came. In India, they call 100 paise, 1,000 paise. In US, they call 100 cents, 1,000 cents. Then they wanted to name the thing too much. So what they have done was they made 100 paise is equal to 1 rupee. Here they got 100 cents equal to $1. Am I right? Because easy to remember. Like we have a 1, 10, 100, 1,000, lakh, crore, everything like that. Okay. We say that 1C, 1 crore. We don't write 1 followed by 7 zeros. It's a short form of representation. So the same way they did here. When they do generate, after generation, they wanted to know what is the difference. You know what they counted? What is the electron difference? Electron difference. And then also they have a measurement. Like we have a 100 paise equal to 1 rupee. Here, they have come out with a measurement called 6.052, I think. You can verify that is 10 power 18 electrons. See that? What's the count? You see that? 6.052 electrons equal to 1 volt. Like you have a 1 rupee, we have a 1 volt. 1 volt equal to how many electrons? This much. Why they have come out with this number? This number was arrived earlier itself by Coulomb. So they wanted to have a same number, they want to take it out. So these are all scientists have arrived. Don't ask me why it is. Don't ask me why 100 paise is equal to 1 rupee. Why not 500 paise is equal to 1 rupee? We cannot say today why 500 paise is not 1 rupee. Why? Who fixed? If you go back to the history, then you will know that when the rupee was invented and paise was invented, they have given a name. Okay. The same thing here. This electrons was made just a 1 volt. Okay. So now 1 volt means there is a difference of so much of electrons, and that becomes static. But when they connected both of these materials through the pipe, a conductive pipe, that means that electron can flow through that. That time, these electrons have gone there. This became 10,000. This became 10,000. Simple. So now it become potential difference become 0. Am I right? The moment you connect, that becomes 0. But when they connect this, the electrons are flowing from here to here. Am I right? How fast it flows. Okay. How it flows. That's a trick. So for that, this pipe is a physical one. The pipe is a physical one. That's what you call it as a conductor, through which there's a small hole is there, gap is there, through which electron can flow. Now, when the electron is flowing through the pipe itself depends on the size. This size, or this size, or this size. That pipe will tell you that, the pipe manufacturer will tell you that how much electron can flow at a time through the pipe. For example, they say that the number of electrons can go through my pipe is 5 into, let us assume that 6.052 into 10 power 18 is 1 unit, 1 volt. And people also say that this is a unit called 1 ampere, and the 1 ampere per second. Okay. not 1 ampere per second, so 1 ampere. That's that 1 ampere. That means that if this many electrons flow through that, how much? 6.052 into 10 power 18. We know all of this. I'm just refreshing you. That's all. You know everything. I'm just refreshing all the concepts. Because this, I have to start from somewhere. I'm starting this possibility. That means that both are same number. Please understand. 1 volt and 1 ampere are having same number of electrons. Now, this is called 1 ampere. That means that if this many electron goes through this path, per second, understand how much? In 1 second, then it is called 1 ampere. That is, within 1 second, this many electrons should flow from here to here. Understand? So, now we understand what is 1 volt. 1 ampere is so much of electron flow. Now, the manufacturer of these conductors will tell you that, hey, my conductor can withstand only 5 ampere. That means that it can only withstand so much of electrons flowing through that. If more electrons flow through that, conductor will get busted out. Okay, that is wrong. That is one. Now, here's a trick. Here is a trick. Think for a minute. I have a water of 100 liters. I have a water of 100 liters. Am I right? I open a pipe and I have a vessel here. Understand? Now, the water can come here 100 liters in per 5 minutes. 5 seconds, sorry. If you make the pipe smaller, then that water can come down. Also, I make a pipe like this. Assuming that I make a pipe like this. But in between, I have a control where I'll be able to make the flow small or less like this. I can make the flow little flow or more flow. Depends on that. So I have a control, the top. If I screw that thing, slowly the screw come here. At one point it will block. Then when I increase the screw, okay, increase the knob. Let's say I have a knob. I screw the knob, then it comes down. Then it blocks the entire water. So what happened? I can control the flow of water either 1 liter per minute or 10 liter per minute or 100 liters per minute. Understand? That is depends on the this one. But there's a trick here. Now, if I have a very big water tank, instead of 100 liters, I have about 10,000 liters. They have a small knob. What will happen? This water will give you so much of pressure that the knob will be broken. So understand the pipe. The pipe also will be, you given a small pipe with 1,000 liters. Then when the water comes here, the pipe will be broken. So please understand, every physical component has a limitation. You should understand that. Every physical component is having, that's going to play a big role for us. That is very, very important for our electronics. Now you may be asking that, how come they are putting 10 billion transistors inside the chip? How they are putting 100 billion transistors inside the chip? Such a small silicon, how come they do that? Yes, that's why I'm saying size of the pipe matters, and size of the knob matters, and the water tank's pressure matters. The pressure also matters. How high it is. So from the ground level, what height the thing? That's what you call the potential difference. That's the gravity difference. Here we call the potential. So what I'm trying to say is that now I have a thing. What is happening is here also same thing. I have two materials. There's a potential difference. And here they have a knob. They have a knob which controls the flow. And it comes here. Now they did a lot of research. Finally, they come out like this. If a potential difference is 1 volt, the potential difference is 1 volt. And if the flow is 1 ampere, then this one is called 1 ohm. Since the ohm is the one who invented this, they're given this. See, everybody they invented, they're given a name. A scientist ampere, they're given ampere. The voltage, they're given a word, V, volt. The ohm is the one, that's why we have Ohm's law also. He is the one who invented this, they're given a, to honor him. Now you know that the frequency we called hertz. Everything we start honoring the scientists who have spent the time. Like that name will be there lifelong. That name will be there. So understand that this they call it as a resistance to flow of electron. If you make less flow, if you make 2 ohms, for example, then the current will be reduced to 0.5 ampere because I make the flow less. If you make it to 10 ohm, then the flow become 0.1 ampere. This is what they did. Maybe for us, it's very simple. We are discussing in 2 minutes, but they spent about 100 years to find this. Not 1 or 2 years. They spent 100 years to find this relation. We are enjoying today. That's fine. So let us take this opportunity to put all the thanks to them. Okay. So we have done they have done a so wonderful job of. There were two great things happen. One is electricity was there in the form of natural lightning. From the cloud, it comes to earth. That's why they have invented this. Same way. So it was a natural electricity, and this is artificial. So they were trying to store. They finally found out it is not possible. That's the reason they found this. All the people. Today it's become very easy for us, but a lot of people have died in these things. Second one was so natural. People were getting the electromagnetic wave from sun to earth. But somebody said that, why don't we generate artificial electromagnetic wave? That's why he did Hertz. That's why today you are having a phone, wireless phone, everything was that. Okay, same thing. Some bird was flying. And somebody found out, why not we invent a nice one of aeroplane. Am I right? So we have to honor them. They are the people, we are living them. We are trying to living for our survival. But somebody thought beyond survival. We have to honor them. Whenever you get the opportunity, honor them. Ohms finds a relation. Before Ohms, Maxwell and so many things just did a very complex one. Finally, Ohms say that, hey, let's go to the common people. So how do you do the common people relation? He found that this, if you call the voltage as a V, if you call current as current should be called C, but unfortunately, they already have a word called Coulomb. The Coulomb is a one measured by, once again, the Coulomb is a scientist. So he measured the electrons. He is the one who said that 6.052 into 10 power 18 electrons equal to 1 Coulomb charge. They measured the charge difference by Coulomb. He was talking about only static, but Ampere is the one who started measuring to the dynamic one. So then came, they measured. That's the reason they start calling this as a current. Current as I, not C. Current as a I, not C. Resistance, they call it as R. So So what they found the relation is so nice. That is, this is the way they did. How they did was, if I apply 1 volt, if there's a current of 1 ampere, then the resistor is 1 ohm. Please understand how they have come out to the resistance. See, normally we normally the college everywhere we have been taught like this. V is equal to IR. Am I right? It's not true. Originally, it was invented by like this. R is equal to V by I. So R is equal to V by I. That's the way they found out the R. Okay. Then they have used 1 R as a standard. With that, they measured so many various types of, that's a 1 ohm. They start measuring 2 ohm and 4 ohm and everything. But the first came was voltage. Then came was current. Then came was resistance. Don't get confused. This is the original formula. But unfortunately, it's boring. That's why we call it as a V is equal to I into R. So this is the way they invented. If you go back and read the history, then you will know that. Yeah, it's not true. That is not the true. That is what I'm trying to say. What you are saying is later formula, which has been made it for you. There's so many. I'll explain to you some more thing also. What as they made it such a way that you will be able to easily understand. That they made things so easy for you. Okay. So please understand, this is a very, very critical one. That is, voltage is the one, the electrons difference, nothing more than that. Whether it's a solar power, whether it is a wind power, whatever it is, what they are doing is they are trying to make a, let us assume that you have a battery. You have a battery in your phone. The phone, you have a battery, which is having plus and negative. That means this guy have a more electron, this guy have a less electron. And actually, proton is not moving from here. There are only 2 particles, plus and minus. Forget about neutron. Plus and minus. This is proton, this is electron. Actually, proton cannot move because too heavy. What is moving is a electron. When the electrons are moving, it moves from negative to positive. Please understand. It moves from moving from negative to positive. This is actually called current. There's a big difference between current and run and flow. We don't call flow, we don't call run, we call current. Why the current? The thing is that actually electrons are moving very, very slow. There's 2 things. Current is the effect of, understand, effect of electron flow or electron movement. Don't get confused between the movement. Movement is actually nothing but a displacement. You displace from X to Y. You move from X to Y. That is called displacement or movement. That it takes few seconds. It takes. But when this guy moves here, you feel the effect here. You know one thing? How fast? 1 by 3 lakh kilometers or so many kilometers. The effect travels. The effect travels. Please understand. The effect is called current. The effect travels from place X to place Y at the speed of 3 lakh kilometers per second. That's the reason when they problem in Meltur, you get it immediately. If you have a 3 lakh kilometers wires. So you understand that. So the effect is current. So since we are discussing about electricity, let us try to understand the few terminology. So the current is an effect, not the actual electron. The electron here does not move here with the 3 lakh kilometers. Electron is not moving at the speed. It is moving so very slow speed. The effect is the one what you get is an effect. That means that your bulb, the electron, what is getting is the electron of next atom's electrons, not the other one, which is started from here. That will come to you very, very late. Please understand. But unfortunately, in 1700, the whole world was with the religious people. Then the scientists, they said that how come a poor can give it to rich? Poor can give it to rich. Am I right? That's not possible. How come water can go from bottom to top? Not possible. Water will come from top to bottom. Rich can give it to poor. But you people are telling that the electrons is given by negative to positive. That is confusing to the whole world. They ask the scientists to rewrite the whole document. Otherwise, you know that they get killed. You know the punishment. The religious people are so fanatic. What they think is because of one guy said, the Galileo said, the earth is revolving around the sun. You know what happened to him. They were so fanatic. They were totally. There's nothing called scientific proof, but not. They are against science. So they have they were threatened to kill all the scientists. Scientists decided, okay, let us do one thing. Let us call two current. This current as an electron current. Electron current means negative to positive. But this current, which is not there, please understand, this is illusion. There's no charges moving from positive to negative. They're all not happening. But it was told to the people to follow, this is what current, positive to negative. Actually, it's not happening. Actual electron is flowing only this way. This is called conventional current. See, name itself say convention. I follow the convention, you also follow. Conventional current. Or it becomes slowly changed into current. Because everything is controlled by the religious people those days. So please understand this. Current, we will always follow like this. I want to give you the information I've told you that. Because that sometimes we get confused how the electrons are. There's no phase and dot here. There's nothing called phase here at all. The guy who has more electron is negative. The guy who has less electrons is positive. Okay. If you take the reference of electron current from here to here as plus, then the current going from negative to positive is negative. That if you call it, that's the phase, that's fine. That's all very related. We'll discuss about them. But all our future references, because I don't want to confuse you, the current means it's positive to negative only. Because that's the way we have been made to believe, and we are believing that. Please understand. This all with respect to this only the whole world is working. Okay. Yeah. No. The less electrons is positive. The more electrons is negative. Please understand. Because electrons is always negative potential. I told you that one small mistake, you cannot call mistake, one small documentation error did by Benjamin Franklin, who called protons as positive, electrons as negative. If you had called the electrons as positive, proton as negative, this problem would have never taken place. That time both the currents will be same. So if there's a less electrons, that means more protons. That means that is positive. If it is more electrons, means less protons, that is negative. So this will affect you when you are discussing about electronics sometime. That's why I wanted to tell you now itself. This. Forget about that. Now, there's one more terminology. Somebody gives you from outside, this was equal. Nothing is, both are equal. Nobody's potential difference is 0 volt. That time, somebody has given a force from outside. Somebody has given a force from outside to make this guy as a positive, this guy as a negative. So this guy sends some force, and you can call this force either power or energy. Okay, both are same. Actually, power and energy are same, but unfortunately, they are not same. You know that we use the term, we use this word interchangeably, but they are not true. Most of you know that. This is all very simple one. Power is actually called, power is a rate. Energy is a integral or total. There's a difference between rate and the integral. Okay, or total. That means that if I am giving so much of force. Yes. Okay. Yeah, power is a rate. And here in our technology, the rate is, in our case, we always talk about per second. I have so much of energy, and per second, that energy is called power. If you give an example, I have 10,000 rupees. That is my energy. I spend 100 rupees per day. I have 10,000 rupees. I spend 100 rupees per day. This is my power of spending. This is my energy. This is my power of spending. My power of spending is 100 rupees per day. Yeah, voltage can exist without power. Yeah, correct. Your battery is there. Your battery is having a voltage. Voltage is a potential difference. That's why I explained to you static electricity. Static, if you don't connect this one, okay, then the difference should be existing. See, I have, somebody is having 15,000 rupees, somebody is having 10,000 rupees. There's a difference of 5,000 rupees. It exists. It exists. Yeah, you are right, perfectly right. No, we give it to both, common, both. We don't give it to positive and negative. The force will act on both. Then only you will get the potential difference. That, if you want to discuss about that, we have to talk about more about how the reactions are taking place, how the magnetic field, North Pole and South Pole. Go and watch the thumb rule, South Pole, and there is a coil which cuts the North Pole, which cuts the South Pole. What is the difference? So one become positive, one become negative. Am I right? That's the way we do generation. When that become bottom now, this become negative. That's why they want to have two things. One is called slip rings, which produces DC voltage. Okay, we have a rings that produces AC voltages. You know that. So these are all the two-word generation that you have studied in the college. But I'm not here to. I'm not here to talk about generation. But I'm going to tell you that what is generation. That means that I have a object, two objects. I give a force from outside. That force, I'm not, this is all mechanical force. We call this a Newton meter or whatever it is. I'm not into mechanical. Okay. But I'm interested in electrical. What they have done is, here they have a resistor. Now, when the electron flows through the resistor, it's a small space. And the more electron goes through the small space, there's a friction. Because of that, this can generate the heat. Understand? I get a heat energy now. What is happening is flow of electron. What I'm getting now? Heat energy. So I give here solar. Please understand. I give here solar. From solar, I convert it to electrical difference, this energy. But after flowing the this could be at, let us assume that at Bhopal. At Bhopal. This is at Bhopal. And there are wires coming from Bhopal to Delhi. At Delhi, at your house, you have a heater. See that? In Bhopal, they give a solar energy and produce the potential difference. And through wires, it has come to your place. Wire is nothing but a pipe. The wire is nothing but a pipe which has gaps through which electron flow. Okay. The wire and pipe are same. So now at your place, you have a small resistance through which when the electron flows, it has a friction, and because of friction, it produces heaters. That's what happened. Think of a minute. Think of a minute now. The same thing, how do I draw now? Now we understand that. Sir, yeah, tell me.
Sir, if you want more current, the resistance must be less, right?
Correct. Yeah, it should be less. Okay. Always. That's the relation is this. V is equal to I into R. That we will discuss next session. But it's how they invented was, if you apply 1 volt, if there's a 1 ampere, then it's 1 ohm. That's it. If you reduce this, then this will, whatever you can do that. That's the we will discuss about that next. It's right. You're right. That this better we have to understand very thoroughly. Now what happened? See here, I produce wheat at Punjab. I produce wheat at Punjab. Then I sold to somebody and got a money. Understand? The money is useless. Understand? I cannot eat the money. I cannot watch the money. I cannot do anything. I cannot sleep on the money. Understand? The money is useless. But once the money is getting converted, I use the money to buy a bed. I sleep. Use the money, I buy a TV. I watch. Use the money, I buy a food. I eat. But you don't worry that how the money is produced. It was produced by converting the wheat to the money. One place. The other place, you are converting the money to the bed and TV and food. You understand now? Is it clear? The same thing here, actually electricity. Electricity is a middleman. It's a middleman. Please understand. Electricity is a middleman. Okay. What happens was, I produce the energy using the hydel power. Okay. In Mettur, in Krishna Sagar, wherever it is. Then I produce the difference. Actually, I generate. I'm not generating, I'm actually converting. I'm converting one energy to other energy. But there'll be a efficiency will be something. You will never get less than 100% always. You will never get more than 100. Whatever energy I give, I'll get always less energy. Then I make it a flow here. Then this is coming as another energy. Could be fan. Please, here is a hydel energy. Water energy. That water is flowing from the dam to bottom. That's hydel energy. Hydro energy, or you call hydro energy, hydel power plant. Now, here you're getting a fan. You understand now? This guy, the whole electricity is a middleman. The money itself came as a middleman. Understand? If you understand that, we understand everything. All electronics, everything we understand later. That's a very tricky one, this one. So this is not great. This is nothing. When one side generation, one side. So what happened? This energy, they found out very surprisingly. What is this power here? Both are same. If you have a power means per second, if you do it for 10 seconds, it becomes energy. If you do it for 1 second, that is called power. If you buy a watt, if you buy 100 watts bulb, that is actually nothing but 100 watts per second. That's the meaning of that. If you use it for 10 seconds, then it become 1000 watts. That's the thing. So if you use for 100 seconds, that is for 10,000 watts. So 100 watts bulb means it is 100 watts per second. You know watts. It's a mechanical thing came because of James Watts. Everything is scientist name, man. Those days, everything is scientist name because they slog and finally found out, and they found out from the horsepower, and then from the horsepower they come from the steam engine. That's the reason they given a thing called watts. So 1 horsepower is equal to 746 watts. That's the way they study. So we start measuring because this is invented the same period of mechanical, 1700. We also measuring this electricity, the power in terms of watts. But watt into second is called energy. Please understand. If I say that watts, then it's power. Watt into second is energy. Both are same. That means if I say that 10 seconds, if we have a bulb of 1000 into 10 seconds, then that is 1000 watt seconds. Am I right? Or you can call 1 kilowatt second. Whatever it is, you can say that. So don't get confused between watt and energy, power and energy. So that means that I give a power. Let us not worry about the energy now. Let us worry about only power. I give a power here, 1000 watts. Could be any way. It could be chemical or whatever it is. This is the energy power I'm giving. I'm getting a power. This middleman takes a power from anywhere. Ramagundam at Andhra, AP. Ramagundam, you know that it's a very big NTPC power plant. And this comes to Bangalore. From Ramagundam, it goes to Bangalore. And this middleman carries that. If you don't have the electricity, there's no way the power can be transmitted from Ramagundam to Bangalore. Understand now? That is such a beautiful one is happening in the middleman. So never say that the traders are. If you don't have a traders, you don't get anything. Somebody is producing something, you are getting. You are a consumer. But in between there is a trader. But unfortunately, the traders makes big money. That is wrong. That is fine. But trader, that doesn't mean that trader is not important. We need to have a thing. So now what they have found was, very surprisingly, I have a voltage, plus minus, and they have a resistance. And you know that they always draw like this because it's a zigzag. This is a normal flow. The zigzag means this is a resistive flow. That's why they made a symbol like this. That means it's not a very straightforward. There's a lot of frictions on the road. You have a zigzag flow. That's why the symbol. Now I draw a wire connected. There is a current here. And this is R. You know that. What they have very surprisingly found is the energy coming out, the power coming out. Power. Let's talk about, because the current is also electrons per second. So let us talk about only power. Let's not worry about energy. Because even though I use the word energy sometimes, it's actually a power. They found out that the power is proportional to I square. Understand? The power is proportional to I square, not I. If I have about 1000 electrons are flowing, if I have 1000 become 10,000, so it's not exactly proportional. It is so the power is proportional to the I square. That's a very, very interesting invention. Normally it would have taken about very long time for them to really find out these things. They have written a big mathematical equations. Today they made this, everything is simple into small multiplications and addition, subtraction, multiplication, division. They made it. If you go to the original Maxwell equation, then they are too good, too great. It has a talk about all temperature. The resistor will change based on temperature. But we don't worry about that nowadays. We call R. Everything same. So there are 5 terminologies. Understand, 5 terminologies. One terminology is V, all about generation. Second one is I, all about transmission. And third one is R, all about resistance or utilization. You can call resistance also. And next one is power per second always. And next one is energy, cumulative power. This is voltage. This is current. And this is resistance. This is power. Same. This is energy. Okay. And the unit is volts, ampere. Ohm. And power is watt. And this is watt seconds or hour, or depends on the how many you accumulate for a few seconds, then it's called watt seconds. If you accumulate for a few minutes, then it's watt minutes. So it has both. It has you have to multiply with this also. So watt into time multiplication gives you energy. So we have a symbol called V. Okay, this we have a thing called RA and ohm and W, WH or whatever it is. Okay, so we mark it like this. VI is the units. Understand them. This is what totally this is 5 is the whole about electricity. Nothing more than that. All about electricity is this. But when you start discussing, you'll be very surprised how these things are turned out to be the such a powerful things. This invention is the greatest one we did it in the what do you call it? Like a wheel. The wheel is the greatest invention. Okay, you know that without wheel, that whole transportation could have not been there. Okay, like that electricity. Like that, there is another big component, transistor. They have been awarded as Nobel Prize for that, the invention. Like the IC. Then there is a gate invented IC like that. So these are all the very nice things. But you should know that how much. Yeah, it is giving it's giving the resistance to the flow of current. That's it. It is blocking the. What is happening is I make like this. Since it's a good question, let me give you the thing. The resistor is nothing but in between the metal there are a free space for the electron to move. If you reduce the free, if I don't have any free space, and if your atoms also having all 8 electrons in the orbit, you cannot move them. They are totally bonded. These are called insulator. The electron cannot move through this. No space at all to move. But here, in these conductors, they have a free electron. There is an electron which is valence electron only 1. If there is a metal which has a valence electron is 1, then I can easily push the electron. And that electron will go. I also having a space in between to move. So they control that. They use multiple materials. Okay. Silicon, copper, and so many materials they produce, and they make a specific resistance. And they measure it. How do they measure it? how much voltage I'm applying, how much current I'm getting. From that, they measure it. No, sorry. There's something called cumulative energy. It's called cumulative power. Work done is energy. Yeah, power in time. Cumulative energy is not. It's called energy itself is the moment you say energy, it is actually called cumulative power. It's called cumulative power. That's called. Cumulative means multiplication, nothing. It's all addition only. It's called power. One second, plus 1 second, plus 1 second, plus 1 second. But we multiply by 4. So the moment I say energy, the word, automatically it's called cumulative, like embedded. The moment I say embedded means hard software. So there's nothing called embedded hardware. Please understand like that. We always use lots of terminology like this. Okay.
Sir.
Yeah.
Sir, my question is that, sir, inside a circuit, without resistor, if you want to connect any, let us say, for suppose if you want to connect a bulb with a voltage source without resistor, what will happen, sir, exactly? What is the use of resistor in that?
Yeah, wait, you're right. Now what happened? I have a voltage source, a symbol, I put a battery symbol, and I conductor connected. Am I right? I already told you that this this one, conductor or a pipe, the pipe itself, that is what wires, itself is having some resistance, maybe less, maybe almost low resistance. Now, because of that, based on the voltage you apply, the current will flow. That is what we're going to discuss on the next session. I'll explain to you more detail on next session. Since we have not discussed more about V is equal to IR, more that we are going to do. Next session, we are going to do the relation between P is equal to I square R, like that. We'll discuss that time. I'll explain to you that what is exactly called. This is called rating. The very important. That's a very important question. What you ask is a very, very important question. This has to be understood by you very thoroughly. If every electronic engineer should understand this. This question is a very, very nice question. Many people don't ask this and or don't get the answer. It's a very good question, and don't forget it. We have to discuss this on the next session. Okay, give me about another few minutes. I'll get it. Come back to you. That we will discuss about the relation between V, I, R, P, and E energy. Am I right? That time I'll explain to you this. This is a very critical one. I do the recording, then we'll discuss about after about